Okay, so what if the reason for one of Earth's biggest mysteries, why its magnetic poles flip, isn't actually buried deep in its core? What if the answer is out there, in the journey we're all taking through the galaxy? Well, today, in this explainer, we're going to unpack a really unconventional theory that claims to connect the tiniest particles you can imagine to the fate of our entire planet. All right, so here's the fundamental puzzle, right? The thing that's had geologists scratching their heads for decades. We know for a fact that our planet's magnetic poles have swapped places, a bunch of times, actually. But the big question, the one nobody has a solid answer for, is why. So like with any good mystery, you've got to look at the clues. And geologists have some really interesting ones, mainly from looking at stuff like the magnetism that gets locked into ancient volcanic rocks. First off, there's no schedule to these flips. They're totally irregular. We're talking anywhere from 10,000 years to 1,000,000 years between them. And some flips are super fast, like the Lachamp event, which happened in just a few centuries. Then there's this. During a flip, the magnetic field gets incredibly weak, dropping to just 5% of its normal strength. And maybe the biggest clue of all, these flips have nothing to do with the sun's own magnetic cycle, which is pretty regular, happening every 9 to 12 years. All right, so here's our game plan. We're going to start with the puzzle, then we'll dive into a whole new way of thinking about charge and photons. From there, we'll see how that builds a model for Earth's engine, how our trip through the galaxy affects it, and even how it solves the mystery of the sun's cycles. Let's get into it. Okay, first up, a planet's magnetic puzzle. Let's take a look at the official story and why some people think it just doesn't add up. So, the mainstream theory basically says it's all about unpredictable, chaotic sloshing in Earth's molten core. Like a giant, messy lava lamp of liquid iron. But the author of the theory we're looking at today, they call that a dodge. They say it's just a convenient story that you can't really prove or disprove, and more importantly, it doesn't really explain the specific clues, like why the field weakens so precisely. All right, section 2. To build a new answer, this theory says we need to go all the way back to square one. We're talking about rethinking the very idea of charge and where magnetism comes from. And this is where things get really interesting. It all comes down to a huge disagreement. See, mainstream physics tells us that charge is just a fundamental property. An electron is negative simply because it is. No one really knows why. But this charge field theory, it throws that idea out the window. It proposes that charge isn't a property at all, but a process, a physical process where particles are constantly recycling fundamental photons. Now, this is a really core concept. It completely redefines what we think of as polarity. The theory says forget positive and negative. It's not about that. It's about the spin of photons. Imagine a tiny particle spinning one way. Let's call that a photon. Now imagine one spinning the opposite way. That's an antiphoton. They're mechanically opposite, almost like two little gears spinning in different directions. Okay, so what does that mean for us here on Earth? Well, this leads to the theory's big claim that right now our planet is bathed in what it calls a charge field that's totally imbalanced. For every one of those antiphotons, there are about 2 photons. And it's this 2-to-1 imbalance, according to the theory, that's actually generating Earth's magnetic field. So that brings us to section 3, Earth's invisible engine. I mean, if this charge field is real, how in the world does it actually power an entire planet? Well, the theory paints a picture of Earth as this giant, self-sustaining engine. It all starts with the planet's rotation. That spin acts like a huge centrifuge, flinging these charged particles out at the equator. This creates, essentially, a vacuum or a negative pressure at the poles, which then sucks the particles back in. And as they get pulled in, they get sorted by their spin. Photons go to the south pole, and antiphotons head to the north. This constant recycling, this endless flow of particles, is what the theory claims is the real source of all that heat inside the Earth. And the implication here is, well, it's pretty radical. It means Earth's core isn't just some leftover hot rock from when the planet formed billions of years ago. No, it suggests our planet is being actively and constantly reheated by this recycling of charged particles, essentially by recycling light itself. Okay, so now that we have this model of a planetary engine, the theory can finally offer a trigger, a reason for those weird, irregular pole reversals we talked about at the beginning. And get this, the trigger isn't something happening on Earth. It's totally external. The idea is that our entire solar system is on this massive journey through the Milky Way. And as we travel, we pass through these huge cosmic patches of space, each with a different mix of photons and antiphotons. And it's moving from one of these patches to another that causes the magnetic flip. So think of our current spot in the galaxy as a photon-dominant region. This is where we get that 2-to-1 imbalance we talked about, the one that's creating the normal magnetic field that we're all used to. But as we drift out of this photon-heavy patch and into, say, an anti-photon-heavy one, we have to go through a transition zone. And in this zone, things get balanced. The number of photons and antiphotons becomes nearly equal. And since their spins are opposite, their magnetic effects pretty much cancel each other out. And that's when the planet's whole magnetic field just collapses. And boom, this is supposed to explain that very specific clue from the beginning. Why does the field drop to just 5% of its normal strength? It's because in that transition zone, the charge field finds equilibrium. It's not totally zero because the Earth is still spinning, but the engine has lost the imbalance that fuels it. Then, once we're through that transition zone, we enter a whole new region of space, one where antiphotons are now the dominant particle. The Earth's engine doesn't change. It keeps doing its thing, pulling particles in at the poles. But now, because there are more antiphotons flowing in, the North Pole becomes magnetically stronger than the South, and the planet's polarity flips. Okay, that's a pretty neat picture, right? But it brings up a big question. If our whole solar system is moving through these patches together, why does the sun flip its poles on a really regular 11-year cycle? Why isn't it in sync with Earth's random flips? Well, the theory's answer is fascinating. It says what we call a solar flip isn't really a flip at all, not like Earth's. Earth's reversals are caused by our galactic journey. But the sun cycle, that's a totally local phenomenon, caused by the orbits of planets like Jupiter. And here's the kicker. During its cycle, the sun's magnetic field actually gets stronger, not weaker like Earth's. So why does it get stronger? The theory claims that when big planets like Jupiter and Saturn are on opposite sides of the sun, the streams of charged particles they send back to the sun collide head-on. Imagine two sets of gears meshing and spinning faster. This collision, it said, spins up the photons. And in this model, more spin means more magnetism. Okay, let's bring this all home. Section 6, a new cosmic model? Let's put all these pieces on the table and see how this one single theory claims to solve all the different puzzles we started with. So, as you can see, the theory tries to offer this one elegant, unified explanation for everything. Earth's regular flips? That's because the galactic charge patches we travel through are all different sizes. That weird 5% weakness during a flip? That's the transition zone, where the charges are balanced out. The sun's regular, predictable flips? Well, that's caused by the regular, predictable orbits of Jupiter and the other big planets. And why does the sun's field get stronger? Because those planetary charge streams are colliding and spinning up. And that really leaves us with a pretty provocative final thought, doesn't it? Could it be that the answers to our planet's grandest mysteries aren't hidden in some massive, unknowable forces deep in the core, but in something as simple and as fundamental as the mechanical spin of the tiniest particles of light?